Good afternoon, everyone, and welcome to the webinar APAC ATMs, Protect Your Fleet's Revenue and Reputation with Testing, sponsored by Clear2Pay and hosted by ATM Marketplace. I'm Suzanne Clucky, editor of ATM Marketplace. Let me start by encouraging you to stay with us for the entire hour and take advantage of the live Q&A session following the presentation. Also, I want to invite you to submit any questions you have during the webinar by typing them into the chat window at the bottom left of your screen. After the webinar, we'll be posting a replay on the ATM Marketplace website. You'll receive an email notification and link, which we hope you'll share with others who couldn't make today's event. Our presentation today will illustrate how automated testing can help you ensure customer satisfaction, mitigate risks, save time, and run a more cost-effective operation. Our speaker today is Chris Milne, a senior ATM consultant at Clear2Pay with more than 10 years experience deploying ATM test solutions for top-tier banks and processors around the world. Chris will give us a live demonstration to show how ATM test solutions can help a deployer overcome persistent operational challenges and maintain maximum performance from an ATM fleet. That said, Chris, I will hand it over to you now.
Thank you very much for the introduction there, Suzanne, and thank you very much for everybody who's joined on the call. So I thought what we might do today is a brief PowerPoint presentation, maybe about 15 minutes. Then we'll do a 30-minute demonstration of one of Clear2Pay's testing tools. Then we'll follow that up with about 15 minutes of questions and answers at the end. So like Suzanne mentioned, just feel free to send in as many questions as you like, and we'll try to get time to answer them all. So perhaps where we'll start today is to ask ourselves the fundamental question, why do we even test? Why do we need to do it? Of course, it's all about maintaining your reputation, making sure your ATMs are up online all the time, and of course making sure that you never hit the front pages of the newspapers reporting any problems with your ATMs. So let's kick things off with a couple of interesting statistics here. So the first one is that 42% of US consumers have reported that their bank's ATMs have been out of service 3 or more times. So, I took a look at that and I thought, hey, that's pretty close to some of the experiences that I've had myself. So when I'm going from the train station to my office every day, I pass about 6 ATMs, and almost every single week, one of them is out of service. So, that's a funny situation because people who are doing that daily walk, they can learn the ATMs that are the most reliable, and they'll also learn the ones that are least reliable. So if you're anything like me, then you'll know the bad ones, and then you'll avoid those ATMs. So that statistic was certainly quite true for me. The second one here is that one of our banks in the US, they reported that one failed interaction needs 7 good interactions in order for that consumer to build confidence again in the ATM brand. So again, I've got a story for that one. So the first time I ever tried to use a contactless vending machine just to get a bottle of water, first time I tried it, I tapped my card and my drink was not dispensed. So, it's going to take quite a few more good interactions for me to be able to build up some confidence in that kind of technology again. So, these are pretty big questions that we need to ask ourselves. But I think the reality is there that if our ATMs are unreliable, then people just won't use them. So what we'll move on to do now is continue our discussion about why do we need to test. What we'll look at next are some of the reasons that we need to do testing. First thing here is unavoidable changes that will come into our ATM fleet. So we've got an interesting quote here that says, most sources of change are driven by external influences. So of course it would be nice if, as maybe a bank or an ATM deployer, if we could control all the sources of change that will come into our environment. But in reality, a lot of this stuff is out of our hands, and it's driven by things like market needs. So perhaps, for example, you're migrating from Windows XP to maybe Windows 7. Perhaps you're even thinking about migrating to Windows 10 when it's released later on this year. We've also got things like the EMV migration and also national chip card schemes too. So all of these factors are coming in, and we know that these changes will require us to do a lot of testing. Just when I was checking my email this morning, a story came in from the Financial Times which was reporting that lots of ATMs out in the field are now at risk because they're still running Windows XP. So, that's kind of scary for the ATM industry because it's now getting into the public domain in such a mainstream publication, saying that there are potentially going to be security issues with these ATMs. So we know that lots of these changes will bring in increased requirements for testing, but fortunately for us, not all of these changes are bad. Some of these changes are good things. So, we've got drivers like EMV that we have to cater for, but we can also think of these opportunities as strategic opportunities for us to improve our ATM capabilities. So maybe if we're updating our ATMs to run Windows 7, for example, maybe we can add a new transaction type. Maybe we can add some advanced new features of the ATM software that we previously could not run on Windows XP. So that's just an example there. So change can be a good thing, but of course we need to balance this, because as we're bringing in all these good changes, we still need to remember that we'll need to test them too. So moving on to the next slide, we talk about the growing cost of testing. So we've already said in the brief previous two slides that we might need to do more testing. Well, unfortunately, as we increase in testing, it also increases the cost of testing too. So maybe as an example, if we're implementing EMV at our ATMs, then that might increase our testing requirements by 5 times. So as an example, we'd now need to do our fallback testing and our downgrade testing, and of course we need to test the chips as well. So new technologies can mean a lot more testing. Perhaps one of the problems we might have is that our projects might start to run a bit behind schedule, and then that's when the cost of testing can exponentially increase. The reason it exponentially increases is because we have lots of non-obvious costs as well. So for example, we might require prolonged support from our IT teams, or maybe we'll find that some of our offshore teams have been benched and they're underutilized. So it's all adding up to the cost of our testing. Continuing on the costs, or the discussion about the growing cost of testing, what I have on screen right now is a slide that talks about one of the major UK banks. So this is the bank that I used to work on site at. And they were aware that this was going to be a big problem. So they took very active steps to try to address these challenges. I'll go through the details of the slide in just a second, but just to give you an overall idea, by taking these steps, the bank saved around £1 million during the implementation of their ATM refresh project. and they have predicted that they will save £1 million each year for this project. So these are pretty big returns for putting in this type of thought up front. So this bank was performing an ATM refresh project, and they were already 1 year behind schedule after just 3 years. So, things weren't running too great. I presume they were getting lots of pressure from their stakeholders. So that's why they needed to take these drastic steps. So the first task that they needed to perform was to identify their problem space. So the things they identified were that the test environment was just too changeable and it was just not robust. So, they'd be trying to do testing with a particular set of cards, and then maybe somebody else wanted to use the cards on the same day, and maybe they'd configured the cards to give a different response from the mainframe system, and then that affects the other person's testing. It's things like that that were causing problems at that bank. What I found is that they weren't the only ones in that situation. In some of these problematic scenarios are actually surprisingly common. Okay, so one of their solutions to that is that they introduced simulators. So rather than having to rely on back-end systems, they would now have simulators that would provide responses to their ATMs when they were testing them. They made sure that their solutions were all integrated, so that minimized the user input, and it made it much easier for the test team to be able to switch between different simulators at any given time. Another thing that they did, which is often overlooked, is that they created and maintained best practices documentation. So everything was well documented about the tests that they would want to perform. A neat thing they were able to do was that they predicted that physical ATM resources would be scarce. So they had a lot of testing to do, and they only had a few physical ATMs to do it on. So they also chose to virtualize their ATMs, which was a real good step in enabling the ATM testers and also the switch developers too to have ATMs that they could run from their desktop PCs. Okay. So they recognized overall that there was a large cost associated with the testing, but they were able to take some doable and realistic steps to reduce the costs of these testing projects. While we continue to talk about costs, the next slide here has some fairly raw numbers for us. So we can see that software bugs cost the global economy $312 billion per year. Of course, that's a very big number. What we're most concerned about is trying to reduce that cost for us. So if you look down the bottom of the slide here, what we see are some examples about fixing bugs at different stages of the project development cycle. So if we fix a bug during the programming stage, like when we're writing code, let's say it costs $1,000. The scary thing is that if that bug makes it through into the system testing, then it's going to cost 10 times the amount to then go back and fix that bug. Even worse than that is if this particular bug makes it into the final release, then it could cost between 10 and 25 times more just to fix that bug. So I guess the takeaway here is that it's much better to identify these bugs earlier on in the development cycle, and that will dramatically reduce your overall costs. So how do you do that? Perhaps an idea or a technique that we could use is to do a lot more automation in our testing. So that's what is currently shown on this slide here. So one of the things that Clear2Pay did a few years ago is we had a look at some of the current issues with manual ATM testing. So I'm sure a lot of these things will be very familiar to people on this call. So we identified a few key things here. The first one is that the only way that the production software can be tested was on physical ATMs. So maybe these organizations were using some sort of message-based testing tool. You know, that's good. It has its uses. Its main use is for testing the host. But the problem is that doesn't really allow the bank to test the actual ATM software that gets deployed onto the ATM. So the problem with that is that there are lots of potential test scenarios that are left untested, and they make it into production without being tested fully. So for example, if there's a broken part on an ATM, like the cash dispenser breaks, then how do you test that early? Really, in the manual world, the only way to do that was to test it on the physical ATM. Of course, that's always a bit risky, and it's a bit of a worry if you need to potentially damage or break one of the physical ATM components just to make sure that the software can cope with it correctly. Okay, so Clear2Pay looked at a lot of these things, and from that, we identified that there was a need for a new piece of ATM testing software. So that's why Clear2Pay invented ATM Test Lab, which is the solution that we'll see in just a second. So what this does is it simulates the XFS compliant ATM hardware. So XFS is the multi-vendor standard for ATMs. So it simulates the ATM hardware, and then it allows the user to fully test the entire software stack of the ATMs. So you can test things like the operating system. You can test things like the antivirus as well. All of that can be tested. Okay, so what I'll do is I will just jump down from the presentation, and then let's just go live onto my screen. Okay, so you can see in front of you right now, I have my virtual ATM. So this is Clear2Pay's ATM Test Lab testing solution. So my virtual ATM has things like a card reader, a PIN pad, a cash dispenser, for example. But the real difference here, and this is quite different from maybe some other testing tools, is that behind the scenes here, I have a whole other virtual machine that contains all of your live production ATM software, and then that's connected up to our simulated hardware. So that allows us to have a real true test of your ATM software's capabilities in exactly the same way as if it was running on a physical ATM. So I'm just going to run through a transaction here just to show you how it looks. These are just our demo screens. What you would see are your own ATM screens here, and it would be your own ATM flow as well. That's because it's your ATM software that's actually running there. So I did a withdrawal transaction there. It was authorized locally and internally within my virtual ATM. But in your live system, the transaction would be sent up to your host, and it would be your host's responsibility to authorize or decline that transaction. So it's sent up to the host in exactly the same way as the physical ATM will send its message. So as far as the host is concerned, it just thinks that this is a physical ATM. Okay, so there's a lot of testing that you can do like this just in the manual world, and that has lots of benefits. So all these problems like maybe your colleague wants to use the same card as you, or your colleague wants to use the same ATM as you, all of those problems, they can be solved within this virtual world because we now create these virtual ATMs that can run on your desktop PC. So lots of benefits there in terms of manual virtual ATM testing. Where it becomes really interesting, though, is when we start to talk about automation. So what I'm going to do is launch our regression test manager component, which is the component that deals with all our test case automation. So let me just browse to our test case database. Right now I have around 70 test cases in my database. Many of our clients will have at least 5,000 test cases. Some of them might even have 15,000. Often the reason for that is that they've got lots of variations for testing, different on-screen languages, different card types, things like that. So of course, we don't quite have time to go into all the features everywhere, but one of the neat things that we can do is we can tag test cases, so it makes it much easier to manage them later on when they're stored in this database. So maybe I can tag my test cases as MasterCard, May 2015 testing, for example. Makes it easy to find them later on. Also, it's a multi-user database, so all of your users can have access to the same test cases. What we'll do is we will run a couple of test cases, and I'll just show you what it looks like when they run in an automated fashion. Let's just hit run, and then let's watch them run. So what I've chosen to do here is to run two test cases. The first one will pass, and then the second one will fail. So of course, failures are more interesting for us because of course that's the goal of testing, is to try to find failures. So if you can see right now, it's actually running the transaction in Spanish. Remember, the first one was in English. Okay, so my results are up on screen, and this is how it would look when you choose to run your automated test cases. What we found is that our clients can run, say, 500 test cases overnight per virtual ATM. So some of our biggest customers will have maybe 10 virtual ATMs. So each one can run 500 test cases overnight. So they can run many thousands of test cases overnight. And that allows them to complete things like their very early testing. It allows them to complete that very quickly. Also allows you to test things like new developments very quickly. So if there's something that you really want to roll out to market real fast, then you can do your automated tests on it, and that will allow you to check it very quickly if it's good or not. Some of our clients in the past, what they've decided to do is once they get the early build of their ATM software, they will actually test it in the virtual environment first before loading it onto physical ATMs. So the idea here is that they can do the test in the virtual world, and if there are any issues that have been uncovered with the automated testing, they'll then just send it back to the manufacturer, and they won't even bother loading it onto the physical ATMs. Okay, so our tests have run, and one of the neat things that ATM Test Lab does is it will log reports of test cases. So there are two main types of reports. So let's just go in and have a look at them. The first one is called a transaction report, and it's a detailed report of all of the technical items that have occurred during this test case. So for example, it shows the screens that were shown on screen to the cardholder. The report also includes the technical details, things like the XFS command data. So these are the commands that have been sent from the ATM software to the ATM hardware. It also contains information like the messages that have traveled between the virtual ATM and the host. So maybe an NDC transaction request message, for example. All of those details are logged into this report. One of the nice things about these reports is that you can save them as HTML, or you can maybe print them as PDF, for example, and then you can send them around to the people within your organization who might need to go off and investigate these specific problems. I remember one story from the past where one of our clients used to report issues to their ATM vendor, and if they found an issue, the ATM vendor then used to need to try to reproduce it on physical ATM hardware. And I think the whole process would take about 5 days for them to get a fix. What that client started to do was to send these types of reports to their ATM hardware vendor. What that meant is that the hardware vendor could identify the issue much more quickly. And I believe they got the 5 days down to about 2 days for a turnaround time for a fix. So that's pretty nice. So that was a technical report of everything that's happened. ATM Test Lab also has the concept of rule sets. So rule sets are user-defined, and they allow the user to define the pass or fail criteria for this test case. So let's just have a look at the first one here. What this one does is it says that after the card has been entered, then the language selection screen must be shown. Then after that, the PIN entry screen must be shown. So what this is doing is it's testing the actual screen content of your ATM software. So this is really neat because if you've got things like foreign language testing, then if you don't have this, then you've possibly got to hire an expert, maybe even a translator in that foreign language, and they will verify if your text is correct. But what we can do with ATM Test Lab is just define a baseline screen. So this is our gold standard or our expected result. It's shown on the left here. Then when we run the test case, the actual screen is shown on the right. So it can compare the latest run against the baseline. And because they match in this situation, it gets a tick. And then that's an overall pass. So these are the types of rule sets that the user can create to analyze their ATM software. I'm just going to go back up, and then let's have a look at a second rule set here. So the rule sets are completely configurable by the user. We have some base templates that you can use to allow you to create them very quickly. What this one does here on screen is this checks the amount that's been dispensed by your virtual ATM. So in this particular situation, it should dispense 0 £50 notes, 0 20s, 1 10, and 0 5s. And in the latest run, it did indeed dispense 1 10 and then 0 of all the others. So of course, that's good. That's exactly what we want. So we get a tick for each line here, and then that's an overall pass result. So these are the types of reports that the rules that we can create that will allow us to perform automated testing on our ATM software. Let's just have a look at the reports from the failed transaction, just to give you an idea of how that might look. So we've got the transaction report, which is similar to what we looked at previously. That's just a technical list of everything that's happened. So let's now have a look at our second screens if I scroll down just a little bit, I see that when my card went in, the first prompt screen still matches. So we were expecting to see the language selection screen, and in the latest run, we did indeed see the language selection screen. So they match, so we get a tick, that's all okay. However, at the next stage, we were expecting the please enter your PIN screen, but what we actually got was the please enter your PIN screen in Spanish. So, I introduced this failure artificially, but you can imagine a situation where maybe your cardholder should receive an insufficient funds response, but they actually get incorrect PIN, for example. So these types of situations, ATM Test Lab can automatically test for. So it will flag situations when the screens are different. You can also right-click and get a high-resolution view of the two screens, just to show you the details. And we also do an XOR function just to highlight the specific differences. Okay, so we looked at two rule sets previously. Let's just look at our second rule set here. So again, we were expecting the ATM to dispense one £10 note, but in fact, this time around, it dispensed 0 10s, but 1 20. So that's flagged as a failure situation because the ATM has dispensed the wrong amount. So it's situations like this that, grab the headlines of the newspapers when the ATMs dispense the wrong amount. So in summary here, the user can create rule sets that will analyze anything from screens content to low-level technical details, and it will verify that the latest run matches the expected results. Once you've created these, you can then just run hundreds of test cases back to back, and then ATM Test Lab will automatically analyze the results. Just when we're in the area talking about reports, another neat thing that we can do is actually generate an animated report. So I've got one running right now in Internet Explorer. So these can be saved very easily from ATM Test Lab. You can just zip it up, and then you can send it around to people within your organization. So that's really cool because it will allow you to maybe do user acceptance testing without people having to stand physically at the ATMs. So that really helps you to rapidly roll out new content for your ATMs. Okay, so maybe if we've got any technical people on the call, let's just have a real quick look at the script that runs behind the scenes. It's really simple. It's written in our quick script language, and we have an API here that gives you details of each command. So you can write the script very easily, very quickly. If you want, you can even record scripts too. So I just hit record, and then I'll perform the transaction, and the script will be generated for me automatically. So we've got all sorts of cool things there about script sharing as well. So maybe I'll write one script, and then that will be shared across 100 withdrawal transactions, as an example. So that allows you to implement test cases very quickly. The reason we have that type of functionality is that, of course, we appreciate that it takes some time to build up your automated suite. So we put as much effort as possible into making it as easy and fast as possible for you to create lots of test cases in your suite. Just a few other neat automated functions here. So we can execute test cases as parts of sets. So you put your test cases into a set, and then you can line them up for execution. So you can execute sets multiple times, and you can hit run to run them now, or you can press schedule, and that will allow you to schedule your tests for a more appropriate time. So maybe you want to run them before your cutover processing time on your host, and then you want to run them afterwards as well. Make sure the test cases still pass. If you have concerns like daylight savings time, you can run the test cases before daylight savings time and afterwards and make sure that everything's still okay. Okay. So at the end of the day, all our results are stored in the database here. All the users can access them, and all the users can generate advanced reports as well. For each test case, one of the neat things you can do is view historic results. So what that allows me to do is see how the results of a test case have changed over time. So maybe on the 1st of April, it passed 100%, but then on the 3rd of April, it only passed 50% of its rules. Because I can see when these failures occurred, it will allow me to much more easily track down the source of the problems within my system. So that kind of stuff is very neat there. Jumping back to ATM Test Lab itself, we've just got about another 5 minutes just to show you some additional features. So, for example, we have a virtual wallet, and that contains things like my receipts. So the receipt is printed for this transaction, and the receipt that will be printed for your ATM software is exactly the same as the receipt that is printed on the physical ATMs. So the reason we can do that is because there's an XFS standard for receipt printing. The wallet also contains all our advanced deposit items, like for example checks, and also note bunches too. So with these media items, what we can do is create an unlimited supply of virtual checks or virtual notes with varying properties. So maybe, for example, I want to do some virtual hardware testing. So maybe I'm going to set this check as being too long. So this kind of stuff is real easy in the virtual world. So I just deposit my virtual check that is virtually too long into my virtual ATM, and then that error response code will be sent up to the ATM software, which is under test, and then that will allow us to verify that your ATM software can cope with a check that is too long. So this stuff's easy in the virtual world, but of course it's a bit more tricky in the physical world, because then you need to worry about actually obtaining these checks and making sure that they're all valid to be used for physical testing. Similarly with notes, we can create notes that are counterfeit and also suspected counterfeits as well. We can also test not a note, so just a piece of paper. So again, these are things that are really easy to do in the simulator and allow us to test that the ATM software can cope with counterfeit notes. So it's a lot trickier to do this kind of stuff in the physical world. Okay, so probably the next thing we'll have a quick look at is our virtual card support. So what I'm going to do is just open up an EMV card. I can see the magnetic stripe data. So my virtual chip card still has a mag stripe. What I can also see are all the virtual chip card data. So I got these data in here by inserting a chip card into my card reader device. It's just like a $10 USB card reader. It will extract all the EMV data, and that allows me to create a virtual chip card. So once my virtual chip card exists, I can do all sorts of cool stuff with the virtual chip card data. So maybe, for example, I want to edit one of the fields. So maybe I can add in some invalid chip data to my virtual chip card. Now, if we wanted to get physical chip cards printed, it would cost like $1,000 to get some new chip cards. But in the simulator here, I can just create them very easily. I can also add new EMV tags. So maybe something like a language preference tag. I can add that in here. So this allows me to create an unlimited supply of virtual chip cards. So it's a lot easier than having to deal with physical plastics. We can also create chip card errors. So for example, when our chip card tries to generate its cryptogram, so generate AC, by default, it will try to succeed. But what we can do is configure the simulator to return an error code. So maybe wrong length. So when your ATM software tells the virtual chip card to generate the cryptogram, the virtual chip card will respond with an error code, and that will test that your ATM software can cope with this error code. That type of low-level EMV debugging is very tricky to do with just the physical ATM. Just as probably our last point here, we'll just have a look at some of the devices that are being simulated. So we have an operator panel. Again, this is just showing me our demo operator panel screens. You would see your own screens here. The reason that's useful is that some of our clients will even use that as training for their branch staff. So you can train the branch staff on the virtual ATM. At the bottom of this window here, we see all of the different ATM devices that are being simulated. What this allows us to do is to create hardware errors on our virtual hardware devices. So for example, with the cash dispenser, I can set it to HW error status. So when the ATM software tries to dispense cash, the dispense will fail, and the cash dispenser will return its status as HW error, and then we can test that your ATM software can cope with that. So that was one particular type of error. We can do maybe 3 different types of errors in our virtual hardware world. The second one here is a specific error for each type of cassette. So maybe in the past you've had to open up ATMs and manipulate the number of notes. What we can do in the simulator here is just use a pull-down menu, and we can choose, say, to set a cassette to have a low status. We can also test boundary conditions as well. Like I can test the effect of setting my cassette to be empty +1, so it's only got 1 note left in it. Then I could then run a test case, and that will allow me to test the effect of running a cassette completely empty. So maybe if you've got things like ATM monitoring software running on your ATMs, then we'll be able to test that your ATM monitoring software can correctly detect that this cassette has now gone to empty. Okay. So one of the most powerful features, and I've left this to last, is that we can override the XFS responses for each and every command that's sent to our virtual simulated ATM devices. So for example, let's look at the cash dispenser device. Here is a list of all of the commands that can be sent to it. So this list is in the XFS standard. So let's say maybe your ATM software will send a dispense command. What we can do is, because the XFS standard is a published standard, we know all of the possible error response codes, and the simulator can return each one to test that your ATM software can cope with it. So maybe let's choose shutter not open. So that would be a shutter jam situation. So what this now means is that when your ATM software tells our virtual ATM to dispense notes, our virtual ATM will return a shutter jam error back to your software. So we're testing that your software can cope with that type of error condition. So there are thousands of these error codes, and they're really difficult to replicate on physical ATM hardware. That's where you get to situations where you're jamming a pen into a slot and sellotaping notes together and things like that. But we can do this really easily in the virtual world, and we can automate it as well. So you can create automated tests that will go through hundreds of these error response codes, and it allows you to really fully test that your ATM software can cope with these. We've done that type of testing for quite a few clients now. Okay, so that was a real brief tour of ATM Test Lab. What I'll do now is just return back to the slides. And I think maybe, Suzanne, are we perhaps ready for some questions now, maybe?
Yes, and we have several that have come in. Thank you for a great presentation, Chris. That was really interesting. Amazing what that program can do. Let's see. I'm going to go to the list of questions that we've had come in and just go through a few of those. Let's see. Domingo wants to know, does this simulator support IFX messages with host?
Yeah, in fact, we've used that at a client in the UK now, and I think one in South Africa as well. So yes, IFX is supported, and yeah, we've had that around for a few years now. It's a nice new XML style messaging format. It's moved on a bit since the old days of NDC. So yeah, that's supported.
Okay. All right. And Matthew would like to know, can this be run totally headless where we turn off the UI?
Maybe not exactly. I wonder, is that perhaps for purposes of stress testing maybe? Because if so, we have additional or other tools that can be used for stress testing. So that would allow you to have maybe 1,000 virtual ATMs on your PC that are, I guess, headless, and they can do, I don't know, 1,000 transactions per second. So yeah, we have other tools that do that, but mostly ATM Test Lab is about functional testing. So we really need everything on display there. I'm not sure if that answers your question, but we'll be giving out my email address on screen. So maybe if you want to follow up, Matthew, we can discuss that in more detail later.
Great. Okay. Yeah, because he might have a follow-up to that with a little more explanation. Let's see. Almaya asks, can I automate the ATM Test Lab with predefined steps like same project, same test set, but trying to test on a nightly build every day, just to make sure to see if the nightly build is not broken, if I understand that question correctly?
Yeah, you can do almost all of that. So almost all of that can be automated. And even beyond that, one of the neat things we can do is interface with Quality Center, or Application Lifecycle Management, as you might call it now. So what you can do there is you can execute the test cases from ALM, and they will automatically execute within ATM Test Lab. So that's pretty cool, because it means that your users don't even need to know anything about how to use ATM Test Lab. ATM Test Lab will just send the results back to Quality Center. So yeah, we can do pretty much all of that.
Okay. Let's see. And Tiago would like to know what happens, this is a good question, what happens if the transaction flow changed? For example, a button changed place or no longer exists. What happens to the replay of the test case?
Yeah, that is a good question. And, you know, it was one of the first things that we identified early on in the development was that, okay, we spent lots of time creating these automated test cases, but how do we maintain them? So, it was a big problem that we found straight away. So we've implemented lots of various techniques for example, replacing all the old screens with new screens. So you can do that real fast. And then one of the things I briefly mentioned was the ability to share test scripts. So maybe, when I come to implement my test suite, let's say I've got 500 balance inquiry tests, what I'll do is I'll just write one script, but they'll all share the same script. So what that means is that if I need to add a new key press, for example, then that will mean that I only need to update that one script, and then it will affect all of the test cases. So, yep, it was a big question, and it's an important question for maintaining the test cases.
Right, yeah. Okay, let's see, we have another question here. What is the way to put tests written in ATM Test Lab under source control?
Oh, that's a good question. I guess we maintain them in our own separate database. So they're all in the database that we maintain. It's not really as advanced as something like SVN or CVS, for example, but it is a database that all the users can access, and it's always backed up as well. We do have some nice features for auditing purposes, like each user has their own unique ID. So if a user logs in and makes a test case, then that will be recorded in an audit trail. So I guess we've got some of that functionality there to allow you to have good control over the test cases. But it's maybe not quite as much as SVN or similar.
Okay. And also, can I test, the same questioner wants to know, can I test for different CEN, like 3.0, 3.2, et cetera, with least effort in changing the ATM project?
Yeah, so you can do that. It's not zero effort, but it is just a little bit of configuration at the start that you need to do. So one of the earliest things that we do when we load up a project here is we define the XFS versions that are supported, so like 3.20 or XFS2, for example. We define that during startup. So all you need to do is change some configuration files and then reboot your ATM, and then it should behave differently now that it knows to use XFS2, for example.
Okay. Moving on from that question, we have a listener who wants to know if you can explain a little more about how TestLab integrates with their virtual ATM. For example, how are you passing key presses through to the real/virtual ATM behind the scenes?
Okay, so yeah, what we would do is we'll take all your virtual ATM software stack, load that into a VMware virtual machine, and then we modify the registry of Windows. So normally it would send hardware commands to the DLL that will go down to the physical ATM hardware. What we do is we manipulate that, so all the commands are sent into the simulator. So the simulator will then do an operation like dispense cash, and then the response will be sent back up to the ATM software. So that's how we handle XFS commands. In terms of things like button presses, if it's maybe like a touchscreen event, what we have is a small listener that will listen to the coordinates that you've virtually clicked on, and then it will send that event into the virtual machine running the ATM software. So all of the touchscreen events are just like Windows events, so Windows mouse keys or mouse presses. So we can just send those same events with the virtual coordinates that the user clicked on, and then that simulates touchscreen event. For things like the key presses, these are passed across at the XFS level again. So the XFS response comes from the simulator, and then that's passed back up to the ATM, or sorry, the XFS interface inside the virtual machine, and then that gets passed back up to the ATM software itself.
Okay. We have another questioner who wants to know, can we deposit all kinds of notes in a single deposit transaction? And I suppose that means, can we test for that sort of deposit within a single transaction?
Yeah, so what you do in advance is you'll configure the acceptable note types, just like you would on an ATM. So maybe a file like BNA, it might be called on your ATMs. That will list all the valid note types supported by that ATM. So all you need to do is add additional types, like US dollars or Singapore dollars, for example, and then you can deposit all of those types into the ATM at the same time. Going beyond that, you can then manipulate the note levels, so like counterfeits and suspected counterfeits. So for each note, you can change the counterfeit status to fully test that the ATM software copes with them.
Okay. And I'm going to try to sneak one more question in here really quickly. This is our last question, and it is it possible for me to test the coin deposit machines and also envelope deposit?
Yeah, that's right. So what you do at the very start is the user creates a project, and then the project defines the hardware type of the ATM. So if I want to test things like coin deposit, I just pick a project at the start that has a coin deposit device, and then the user interface of the virtual ATM will change dynamically. So it will now show a coin deposit slot. Same thing with the envelope deposit. It will now show an envelope deposit slot.
Okay.
So
that's it.
A lot of
go ahead. I'm sorry.
Oh, no problem. So we support all of the devices that are defined in the XFS specification, and Clear2Pay is also a member of the XFS committee. So, you know, we have to implement all these devices in order to support the standard.
Right, and that would be in also in multiple vendors as well.
Yeah, that's right. In fact, some of the world's biggest ATM hardware vendors actually use ATM Test Lab to test their very base release. So, you know, just some real base builds, doing low-level testing, they use ATM Test Lab. So, of course, that's good for lots of our other customers because it means that we have to implement these new devices really quickly so that the ATM hardware vendors can use them. So it's quite likely that if you have a new device, then we'll probably implement it before it ever comes out to you because the hardware vendors need it real quick.
Oh, good to know. Well, unfortunately, we are out of time for this conversation, but I hope all of you in the audience will stay connected to the topic by visiting atmmarketplace.com. I want to thank all of our questioners for submitting their questions today. If you asked one that we didn't get to, and I think we did cover them all, but if you have one later that you didn't ask today, you can email it to Chris at chris.milne@Clear2Pay, that's Clear2pay.com. Thanks again to our sponsors at Clear2Pay and to our speaker, Chris, and thanks to all of you for listening and taking part. Have a great day.